With what velocity should a particle be projected so that its height become equal to radius of Earth? So our aim is to find out with what velocity an object should be projected from the surface of Earth. So let's say we are projecting an object of mass m, we are projecting from here with a velocity, take it as nothing but u, so that it is able to reach a maximum height which is equal to radius of Earth. So in this type of question, as the distance is very high, we can find out the answer by using conservation of energy. We can just say that the total energy at point 1 should be equal to the total energy at point 2. So total energy is sum of kinetic plus potential. The kinetic energy at point 1 is half into m into u square, plus potential is not equal to 0. Potential is gravitational potential minus of g mm divided by r, where r is the radius of Earth, should be equal to total energy at point 2, which we can take it as nothing but kinetic energy is 0, potential energy is minus of g mm divided by r plus r, which we can take it as nothing but 2r, distance from the center of planet. Should not use mgh for the equation for the calculation of gravitational potential energy. So we can find out the value of this u over here. First of all, we can cancel this m and this m over here. So we can write this u square by 2 is going to be gm divided by r minus gm divided by 2r. Or you can write this as gm divided by r into 1 minus 1 divided by 2. So we can write this as the value of u square is equal to nothing but gm divided by 1 minus 1 by 2 is nothing but 1 by 2. So it is 1 by 2r. So this is u square by 2. So this 2 and this 2 get cancelled. So we can write the value of u as equal to root of gm divided by r. A root can be written as nothing but gm divided by r raised to 1 by